The Westgate Bridge collapse occurred in 1970 in Melbourne, Australia, during the construction of what was planned to be one of the longest steel box girder bridges in the world at the time. Unlike many engineering failures that happen after a structure is opened and put into service, this collapse occurred while the bridge was still under construction. At this stage, the structure had not yet reached its final form or strength, which made it particularly vulnerable to instability. Because of this, the Westgate Bridge collapse is widely recognized as a construction stage engineering failure. It highlights how decisions made during construction can be just as critical as the original design itself. The Westgate Bridge was designed as a steel box girder bridge, a common choice for long-span bridges due to its structural efficiency. A box girder consists of hollow steel sections that provide high strength while using relatively less material compared to solid beams. This efficiency makes box girders ideal for spanning long distances, but it also introduces certain risks. Because the steel plates that form the box are relatively thin, the structure relies heavily on stability rather than sheer material strength. If loads become uneven or if the structure is not properly supported during construction, these thin plates can become susceptible to buckling. This sensitivity makes box girder bridges especially dependent on careful analysis of construction stage conditions. During construction, engineers discovered that the two sections of the bridge deck were not aligning as expected. A visible gap began to form between the steel box girder segments. This misalignment indicated that the structure was already experiencing unexpected deformation during construction. At this stage, the bridge had not yet achieved its final structural form, meaning it lacked the full stiffness and load distribution it was designed to have once completed. But instead of treating this misalignment as a warning sign requiring full structural analysis, it was viewed primarily as a construction problem that needed to be corrected in the field. To really understand why the collapse happened, we have to look at a decision that was made to deal with the misalignment issue. At this point in construction, the bridge wasn't complete yet, but there was pressure to keep things moving. The misalignment between the steel box girder sections was treated more like a construction problem that needed a quick fix instead of a structural issue that needed to be fully reanalyzed. The solution they chose was to add concrete ballast to the structure. The idea was simple. By adding weight, gravity will help force the steel sections into alignment. From a construction standpoint, that probably seemed reasonable at the time. The problem is that from an engineering standpoint, adding that weight completely changed how forces were acting on the structure. Steel box girders are thin-walled, which means they rely more on stability than on mass for strength. When extra weight is added, the steel plates go into higher compression. Steel plates under compression don't fail by snapping. They fail by buckling. Once buckling starts, the structure loses stiffness really fast. In this case, the added concrete created compressive stresses that the box girder was never designed to handle during construction. Those stresses were also concentrated in certain areas instead of being evenly distributed. What makes this worse is that no full structural reanalysis were done before the ballast was added. So the engineers didn't actually know whether the structure could safely handle those new loads. As the compressive stresses increased, the steel plate buckled. Once that happened, the box girder lost stability. And because this type of structure doesn't have much redundancy, the failure happened suddenly. This collapse shows an important lesson in engineering. A change during construction can be just as dangerous as a mistake in the original design. The added weight didn't just fix alignment, it changed the entire load behavior of the bridge. The collapse of the Westgate Bridge was not caused by a single calculation error, but by a failure of engineering process. Temporary construction loads were not treated with the same level of importance as final design loads. Communication between designers, contractors, and engineers was unclear, and responsibilities were poorly defined. There were also no independent structural review to evaluate the safety of the field modifications, and no clear authority empowered to stop construction when unsafe conditions develop. As a result, decisions with major structural consequences were made without adequate engineering oversight. Following the collapse, major changes were made to engineering and construction practices. Temporary works and construction stage conditions began to require full structural analysis rather than being treated as secondary concerns. Field modifications could no longer be made without approval from qualified engineers, and independent peer reviews became standard practice for complex bridge designs. Improved construction monitoring and safety procedures were also introduced to ensure that early warning signs of instability were not ignored in future projects. The Westgate Bridge collapse had a lasting impact on the field of engineering. Construction stage loading is now recognized as just as critical as final design loading. Box girder bridge designs became more conservative with greater emphasis placed on stability and redundancy. The collapse also helped establish construction engineering as a distinct and essential discipline within structural engineering. Today, the Westgate Bridge disaster is widely taught in engineering programs around the world as a reminder that engineering responsibility extends beyond design and includes construction, communication, and oversight. Thank you all for viewing my presentation. AI tools were used to help assist my research topic and organizing my presentation. All narrations and all explanations were my own. Thank you so much.